from faculty members or professionals who work on these areas from across the world, and for the benefit of our own university, students and faculty, and also as an outreach work with our partners with whom the Office of International Strategy and Mobility engages. Professor Arkaja Chakravarti has joined us this term, who is part of our growing faculty cohort, and has a very strong background in technology and finance. Her work is empirical in nature, and works on corporate finance and labor economics, which are two very different fields from the perspective I come. But it's very good to see that she is able to engage two different fields in her work. She has she is right now based in Melbourne. I'm hoping that as soon as we get back to campus, we'll be able to meet her in person, and we'll be able to learn more things from her. But at this point, I would like to, without any delay, invite Professor Arkaja to start her lecture, which is titled Labor Mobility and Economic Value of Corporate Innovations.
Thank you, Fazil. Thank you so much. Thank you so much for such a kind introduction. Before I begin, I would like to thank the organizers of Jsbf NIFTI lecture series for giving me this opportunity, in particular Fazil and Ashavari. Let me correct myself, Professor Fazil and Professor Ashavari. My language needs to. So this paper essentially took shape 3-4 years ago, when I had started to combine the labor economics, basically the regulatory changes that restricts or influences labor mobility across firms, and that effect on various aspects of corporate decisions. So since innovation lies at the center of economic development and other public policy aspects, I think it's a very pertinent question. So this paper I have co-authored with Harminder Singh and Ning Gong, who work at Deakin University and who were also my advisor for the second PhD that I was doing. So without further ado, I would like to take you to what really motivated this research motivation. And before I begin, I would request you to please let me know about the time, because I'm not able to see the clock on my laptop. So innovation lies at the center of any economic development or growth. So it does not require any further establishment, because the idea has been around since 1957, as Solo said, that innovation plays a key role in any economy's growth. Further that argument, what we find in today's times that USA, which is the largest economy of the world, almost half of its GDP growth actually comes from corporate innovations. So it doesn't really require any further convincing that why public policy makers or the regulators emphasize so much on building an environment that promotes innovation or innovative ideas. And what exactly lies at the center of this innovation output is the human capital. And that is why we can see that the constant or the exodus of workers, or especially high-skilled workers from one firm to the other, has always been a concern for the employees, and they have various instruments they use various instruments to curb that exodus. For example, most of the startups issue stock options to employees in addition to the salary, because that kind of aligns their future interest with the company's growth itself. So human capital is an important aspect of firms' ability to innovate. So these innovation projects tend to be a long-term, multi-stage, and labor-intensive. And what hampered this innovative output of any company is the employees' job hopping attitude. And it's really, and sometimes job hopping happens without any external incentive. An employee just decides to have their own startup, or sometimes on occasions employees have been known to be poached by a competitor. And there are multiple incidences where we see the court cases, the incumbent company or the ex-employer files a lawsuit against the former employee. So what I want to do in this, what I want to study in this paper, what we actually do is study in this paper is what happens when employees are restricted to freely move across firms. What happens to that restriction to their mobility on firms' innovation output? The reason what makes it more interesting, because the outcome is not very obvious ex ante. So there are contradictory empirical evidence in the literature so far. So on one hand, what researchers have documented that stricter enforcement of non-compete agreements, which in a sense restricts workers' movement across firms, that results in reduced capital expenditure per employee. So higher is the probability of workers leaving a firm, lower is the inclination of these firms investing in their own future projects, which is one way to estimate that is the capital expenditure of firms. And second paper, which is relatively more recent, where the find is stringent trade secret protection results in reduced innovation output by firms. So one trade secret protection, here I would like to mention that key employees of the firm, the scientists, the engineers, the key executives of the firm, they have access to these key, the trade secret of a firm. So the main difference between the key aspect of trade secret lies in the secrecy of these ideas. So they have not yet filed for patent. So the information about that innovation or the project is not public. And so until the patent has been filed for and granted, this remains, this takes up a form of trade secret. And engineers and scientists who work on these projects, they have access to these trade secrets. And they are very important to give a competitive advantage to firms. I mean, if I can bring your attention to the famous Google Waymo versus Uber case, where one of the Anthony Lewandowski, who was a former employee at Google Waymo, he left the firm, took the data with him, and put up a startup firm, which was eventually bought up by Uber. So Google filed a lawsuit against Anthony Lewandowski and Uber because there was a trade secret theft. So there is a huge undercutting of a firm's competitive advantage, and which might result into their reduced investment into their own future growth. On the other hand, what researchers have documented is enforceability of non-compete agreements has increasing effect on investment rates. So the other side of the argument is that higher the enforceability of non-compete agreements, they have higher investment rates. And then again, what the more contrasting finding was the stringent trade secret protection results in higher R&D investment. So if I could compare the stringent trade secret protection resulting in reduced innovation output, where the authors measure innovation output in terms of number of patents granted and weighted citation of those granted patents, vis-a-vis the R&D investment, there seems to be a conflict. So the question we were scratching our heads with, does it imply that the better trade secret protection results in suboptimal R&D investment by the firm? And this kind of set up the premise for the paper. Further on, what we found was that there was a law passed by different states in the USA at different time called Wrongful Discharge Law, where employee can file a lawsuit against their employer where for the unethical discharge or firing of these employees. So once this, and the adoption of this wrongful discharge law resulted in higher job protection of these employees, which in turn resulted in higher innovation. So there is this there is not much clarity ex ante that what would be the restriction on labor mobility would result in the innovation. So what we argue in this paper is, unlike the other paper which focuses on patent numbers and patent citation as the proxy for innovation output, we are solely going to focus on the firm's economic value of innovation. Especially because there is a contrast evidence, because on one hand, we have evidence of higher R&D investment following stringent trade secret protection. On the other hand, what we have is reduced number of patents granted, which might be suggestive or indicative of the fact that there were reduced number of patents filed. So what we are saying that the higher, first of all, we should not solely focus on number of patents granted and patent citation, because not all patents are equally important. Because when we say that, when we just look at the numbers of patents granted, we are by default giving equal weight to all the patents, which might not be the case, because only 5% of all active patents are ever licensed or commercialized. And second, and what other articles have also argued or found actually, that most companies used less than a quarter of the inventions they own. So what we can see that even if they get the patent grant, almost 75% of the patents really are inconsequential for these firms. For instance, I would like to discuss a case that there was a patent granted to IBM in 2001 for a system and method of providing reservation of restroom use. So this patent, based on its citations as well, it would come to the top 20% of the patents granted ever. So it was heavily cited, as well as it was granted 2001. However, this patent has no economic significance for the firm itself, for IBM itself. So what they ended up doing is that they stopped paying the annual renewal fee to the US Patent Office, USPTO office, and the patent now has lapsed. So even if on the basis of citation, as this seems to be like one of the best patents granted, one of the best patents for IBM, it did not translate into any economic value for the firm itself. Furthermore, what Abram et al. Find that the relation between patent citations and the values is inverse view. So the relationship is not linear. That's why there is a lack of clarity of relation between the citation and the value. We think, since as shareholders, it is basically the firm value that we care about, and firm value coming from innovation, we should focus more on the economic value and not so much on the patent grant itself, because that could be misleading. Also, if you look at the, before I go further, let me tell you how we estimate economic value of innovation. We refer to Kogan et al., that is a 2017 JFQA paper, where they float a new measure of innovation by citing this similar concern that not all innovations, maybe academicians have been putting a lot of emphasis on the number of patents and citations instead of looking at their value. So the way they estimate an economic value of an innovation or patent grant particularly, that by measuring the product of an estimate of cumulative abnormal return, which is CAR, of the stock upon the announcement of the patent approval, and the market capitalization of the firm that receives that patent grant on the day before the announcement. So if I can sum it up in another language, then whatever the change in market capitalization of the firm happens over and above the previous day's market capitalization of the firm, and whatever the index movement would have allowed it to change, if the delta, the difference of this estimate is what they argue is driven by the value of the innovation, value of that patent grant in that day. And what we do is we sum up all the values of each patent grant by a firm in a given year, and we call that was the patent value of a particular firm in a given year. So when we do that and sum up it for all the firms in a given year, if you look at this chart, the blue line represents the number of patents in a given year, and the average patent value represents the average value of the patent in a given year for all the firms that we have in our sample. So if you look at these two graphs, maybe there was some pattern around, say, let's just say 1995, maybe. But the change certainly happens during the dot-com crisis. You'll see that the market was valuing a lot of innovations as a highly valued, where just going by the number of patents, that does not reflect a lot is going on in the market. And the pattern starts to completely disengage after the dot-com crisis. So the event, but then there would have been endogeneity concern, and the way how we measure the change in the labor mobility restriction. So in order to address that issue, what we use is an event called inevitable disclosure doctrine. So we use the recognition of inevitable disclosure doctrine, IDD. I'll keep calling from henceforth, I'll call this doctrine as IDD, by different state courts at different time period in USA. So IDD strengthens the legal protection of firms' trade secrets by curbing labor mobility. So what it essentially does is, if an employee is has resigned from its former employer, from the former company, and is about to join a competitor, but the former employer is not sure that this employee will be going to divulge the trade secrets or the knowledge that he has gained in the previous firm, then they can file a lawsuit, and the court compares the merits of the arguments of both the sides and then favors in whether the joining of a new job will result in the disclosure of trade secret or not. And if it does, they can prohibit, the court can rule in favor of former employer and prohibit the employee to join the firm, the competing firm that he or she is planning to. So this IDD strengthens the legal protection of firms' trade secrets by curbing labor mobility. And I think that the strongest aspect of this IDD is the fact that all the company has established is there is a cause for, or there is a case for threatened misappropriation. Even they don't have to establish a wrongdoing from the employees on the employee's behalf. Instead, even if they establish there would be a chance that this employee is likely to divulge the secret, that's good enough a ground for court to give a verdict in favor of the former employer. And also the fact that even if the employer and employee have not signed a contract which stipulates non-disclosure agreement, NDA, or non-competing clause, NCC, even if these clauses are missing from the contractual agreement, employment contractual agreement, IDD is effective at just as much. So IDD leads to it has been documented that IDD leads to reduced mobility of scientists and engineers, and we all know that they are the key, they are the center of any firm's innovative ability. So just to make my case for threatened misappropriation in the context of IDD, let me spend 2 minutes on Pepsico versus Redmond case, which is a very famous case in the context of IDD that happened in 1995. So Pepsico back then brought an action seeking preliminary injunction against his employee called William Redmond from accepting a position with PepsiCo's competitor Quaker. Back then, Quaker had a sports drink called Gatorade, and that was a primary competitor of other sports drink with Pepsi. And Pepsi wasn't sure that William is going to divulge the trade secrets that he has learned at Pepsi to Quaker to give competitive advantage to Quaker when he joins the firm. He has worked in Pepsi for over 10 years, and PepsiCo argued that his Redmond's joining of Quaker was very, it seemed unethical on a prima facie, because he did not divulge to his superiors at PepsiCo that he was going to join. It did not have enough disclosure that an employee was expected to do. So on the basis of those arguments, the district court granted an injunction against Redmond from assuming his position at Quaker for a period of 5 months, and also preventing Redmond from using or disclosing PepsiCo's trade secrets. So courts take these trade secrets, courts in USA take these trade secrets very seriously, and IDT has furthered their companies' ability to protect their trade secrets legally, especially after the adoption or recognition of IDT by the High Court of the state. So what we're looking at this graph is there are 3 kinds of states. So, and it is not, I would like to highlight the point that it is not necessarily the case that if a high court in a state has recognized IDT at some point in time, it is likely to continue with that in the future. So there might be a reversal of that recognition, and when that happens, we say that IDT was adopted, but it was followed by rejection. So the blue states in the graph are the states which adopted IDT and stayed with that. Green states in the diagram are the states where these states adopted IDT, like Texas, Florida. They adapted IDT at some point, but then ended up rejecting it in the later years. And the yellow states are the control states where they never adopted IDT to begin with. What are the main results? What we find is that following recognition of IDT, firms' value of innovation output increases vis-a-vis those headquartered in states that never recognized IDT or which revoked IDT in later years. What we also document is that these firms also experience more efficient R&D investment. We measure research quotient, the parameter which we found on Word's database. And what we find that not only it's the economic value of innovation increases, but the investment efficiency of R&D expenditure also increases following the adoption of IDT. So we bridge the gap in the literature by offering an explanation for contradictory finding, where researchers have documented the reduced patent grant following stringent trade secret protection versus increased R&D investment following stringent trade secret protection. What we find actually that if the workers are restricted to move across firms freely, firms are more willing to make investment in their own in their future growth, because they know that the ability of these employees to run with those knowledge, that knowledge acquired is reduced now. So let me take you to the empirical setting so court's rule first and foremost is I would like to establish there is the exogeneity of IDT, that it was not it was not a law that was passed, and that is why we can safely assume that it was not affected by other corporate activities like lobbying, etc. Instead, the recognition of IDT happens when courts rule on legal disputes between employee and employer. Is favored favored for the employer, and the argument and the verdict mentions the argument for IDT. So once the first time it happens, that's where we assume the IDT has been recognized. And this cannot be predicted. This is very inconsistent. There is no pattern there. And that is why we can assume that this is a fairly exogenous event. And also that state level factors do not affect the likelihood that a court adopts the IDT. It has been established by a JFE paper, Class et al. In 2018. Based on these 2 arguments, we believe the IDT is exogenous event in our context as well. And second, why we consider when I talked about that firm's headquarter, where a state high court has accepted the IDT or not, the reason is the way we classify a firm into a treatment or a control group is because whether the firm is headquartered in a state that has adopted IDD. If that was the case, then the firm was classified as treatment firms. Whereas if a firm is headquartered in a state where the state high court has not recognized IDD ever, then these firms are called to be the control form are forming the control group. So the reason why we refer to the firm's headquarters state is because the protection of trade secret mainly come under the purview of state laws and legislation. And it has been shown that the large firms locate their R&D facilities close to the company's headquarters. And if that is the case, then the firm headquarters becomes a decently reasonable reference point for us, especially when we're talking about IDD. Furthermore, what researchers have argued that protection of trade secrets come under the purview of employment laws, and these employment laws are actually comes under the jurisdiction of the state court. And based on these arguments, we refer to the firm's headquarters state for the classification of treatment and the control group. So we have a patent, a citation weight patent, and market value of patent. So this market value of the patent is what we are focusing is the primary focus area of our paper. We obtained that from Noah Stoffman's website. His data is available until 2019, but since our IDD data is available only until 2016, we have to restrict our data from 1950 to 2016. We obtain other firm level parameters like total asset, liabilities, etc. from CompuStat, and firm headquarters state is taken from Edgar because it's been documented before the headquarters state that is mentioned in CompuStat could be riddled with problems. So what we refer to is the 10K filings of the firms, and when whatever address that they have mentioned, that's the state that we take as firm state headquarters. For the firms with missing 10K filings, or we couldn't obtain that in text format, we keep the CompuStat reported headquarters state. And what we implement here is a difference in different methodology, because that gives you a cleaner causal inference of or effect of an event which in our case is IDD adoption on the average patent value. So we estimate average patent value is the total patent value of a firm in a year divided by the total number of patents granted to that firm in that particular year. So basically, higher the average value of the firm, the more worthwhile project they have undertaken, and market also responds accordingly to those innovations. And we are starting with an assumption that market is right. Market knows what the future value of these patents and the projects are. So in this equation, we have a state fixed effect. We have industry into year fixed effects. The reason we do not have firm fixed effect because a high innovative firm will tend to, the innovation of a firm tends to be a very sticky variable. But then in order to control for changing attributes of an industry, of any industry, we control for industry year fixed effects, which is represented by alpha JT. And our main we control for various various firm level parameters like firm size, estimated as firm's total asset, firm's leverage, etc. Our main coefficient of interest here in this equation is beta, which estimates the difference in estimate for adoption of IDD, where IDD variable takes states they have adopted IDD in a given year and zero otherwise. If I can explain that further, so let's say there are three kinds of state, as we have seen in that graph. That first state is control state, which never adopts IDD. So for that, these days, all these variables, IDD will be zero for all the years. Let's say there's a second kind of state where IDD was adopted in year N. So until year N minus 1, the IDD variable itself will take 0, and from year N onwards, IDD will take 1. And there's third kind of states where, let's say IDD was adopted in year 2, but later on rejected in year N plus 2. So IDD will take 1 only from year 2 to year N. And from after n plus 1 year, rejected n plus 2. So from n plus 2 onwards, the IDD will be IDD will be taking a value of 0. So this is the construction. So IDD essentially captures the difference in difference estimate. So this is the main result, and that is the main research question that I have been building up to. That in the first column, we have in the first and second column, I have nominal value of average patent value, and in the third and fourth column, we take the effect of inflation out, and that is what, and hence we are reporting real average patent value. So in both the cases, we see that adoption of IDD has resulted in increased nominal value of average patent, as well as it has also resulted in increased value of real patent, increased value of real economic value of patents. Although as you would have expected, the extent of the effect is more subdued in case of real patent value vis-a-vis average nominal patent value, because the column 3 and 4 we have taken away the effect of inflation out. The first and the third column, we do not have any firm control because we just wanted to see the preliminary effect. And in the second and the fourth column, we have the firm level controls like total asset, leverage, profitability, etc. Now, although we have floated floated arguments in favor of why IDD would be exogenous in our case, but to further establish that empirically, what we do is we follow Mullainathan's paper. I think that was published in 2013, where they argue that in order to establish that there was no omitted variable bias which was induced because of this event that we are using, we should divide the event indicator variable into different time period. So what we essentially do is we divide IDD into 4 variables, basically. First variable is IDD adoption -1, which takes 1 for the 1 year before IDD adoption and 0 otherwise. IDD adoption 0, which takes 1 only for the year of IDD adoption and takes 0 otherwise. IDD adoption 1, where it takes 1 for the year, 1 year after IDD adoption and 0 otherwise. And I would also like to mention that whenever these values are taking 1, it's only for the firms which have adopted IDD, because for a control firm which are headquartered in states which never adopted IDD, these variables are always going to take 0. And the last variable, the fourth variable that we constructed out of it was IDD adoption 2+, which means it takes a value of 1 only for the second year onwards after the adoption of IDD. So when we run this regression, again, the first and second column represents the effect on nominal patent value, and third and fourth column represents the effect on the real patent value. So when we run that regression, what we find is the effect is observed predominantly during the last, from the second year onwards on the innovation. And the fact that there is no statistical significance of IDD adoption -1 further establishes that there was no relation between IDD and the innovation output between the treatment and control firm before the IDD adoption. Actually, IDD was recognized. So having established that there was no endogeneity concern, the next we checked what happens to the research and development efficiency, investment efficiency, because we have documented that the economic value of patents go up. So and what researchers have further documented previously, that although the R&D investment goes up, the number of patent grants goes down. So the second question organically comes out of it is, what happens to R&D investment then? So when we check for that using Knott's 2008 measure, it was published in Management Science, what he floats as a measure of research quotient, where it represents the percentage variation revenues from 1% increase in R&D, holding everything else constant. So this, in effect, measures the efficiency of the R&D investment. And when we run that regression, what we find is IDD also results in the significant increment of research quotient. And I think if I can translate this number into economic significance, I think IDD adoption has resulted into approximately 5% increment in research quotient following the adoption of the recognition of IDD. Here also, we have used the same fixed effects as well as the firm's control variable, but in order to close this, just remove the noise, I'm not showing the control variables coefficient. It's there on the paper though. So what we test next is where the cross-sectional heterogeneity of this response, because not all the firms are innovative, not all the firms are equally innovative. And what we want to find out that what kind of firms get to benefit more from the adoption or recognition of IDD. So the first category of classification that came to our mind was the industry. So there are industries which are at the cutting edge. IT, for example, pharmaceutical firms, they innovate a lot. They file for a lot of patents. IT sector, they are very innovative. They file for a lot of patents. So there are, in comparison to, let's just say, a manufacturing firm or an oil company. So these companies, in comparison, they are not as innovative as pharmaceutical on an average, or IT firm. So there is a classification available that classifies industries based on their innovation output. So industries with high innovation output are called new economy industries, and industries with low innovation output, they are called low economy industries. So based on, we use this classification and create a dummy called new economy. It's an indicator variable that takes 1 if a firm is operating in a new economy industry and 0 otherwise. And we interact this indicator variable of new economy with our difference in difference variable called IDD. So it's, in essence, it's a triple difference model. And what we find is, so beta 2, the coefficient of IDD in this cross-sectional test, what it represents is what happens to the patent value of the firms operating in non-new economy industries, where the new economy firms actually has taken the value 0. And what this beta 1 captures is what happens incrementally to the patent value when the firm that operates in new economy industry, but also is headquartered in a state that has adopted IDD. So what we see is that the incremental effect. So yes, the effect of IDD on the firms, on the innovation output of the firms which are not operating in new economy industries is positive, which is great. But the firms which benefit even on the top of it are the new economy firms. And what we find is the incremental effect is statistically as well as economically significant for these firms, both for the nominal value as well as the real value of the patent. And what beta 1 plus beta 2 tells you that so beta 1 tells you the incremental effect, and beta 1 plus beta 2 tells you the overall effect of IDD on the firms operating in new economy industries. So based on this, what we observe is the extent of the effect of IDD on the firms which are not operating in the economy is a little bit muted in comparison to the firms which operate in new economy industries and also headquartered in the states where IDD is recognized. 1.28 in comparison to 2.53. And the same holds true for the real value, because 0.64 coefficient of for real average patent value compared with 1.438 of coefficient. Second, what we argue is, what we wanted to test out is what happens when when firms are or industry is more dependent on the skill set of workers. So there is, I'm not able to recall the author's name, but this data is publicly available, has been made available by the authors. And what they do is they look at the skill set required for firms operating in a particular industry. And if we use that data to divide firms into two groups. If the firm's labor skill is above median, then we classify that firm as high labor skill industry. Sorry, it is industry-based measure. So we classify that industry as high labor skill industry because of the fact that it is more dependent on the skill set of workers, and when it's likely to lose its key workers, skillful workers, then it's likely to lose out on its innovation output. So high labor skills here, it takes it's again an indicator variable where it takes one if the labor skills of that industry, the dependence of an industry on its labor skills is above median and zero otherwise. So Beta-2 tells us that what is the effect of IDD on the patent value for the firms which are not as dependent on the labor skills. Then we find that the value of the real as well as the nominal value of the patent increases with IDD adoption. However, what is more interesting to document is the effect of the IDD or the incremental effect of IDD for those firms which are headquartered in those states which have adopted IDD, as well as they are more dependent on the labor skill set. They stand to benefit more in comparison to their peers which are operating in the low industry skills requirement. So, and the effect, again, the total effect on the higher labor skill industry is much more accentuated in comparison to those firms which are not operating in so skill dependent industries. So these are, I would say, these are all desired effect of IDD, that once firms are provided better legal protection, then they are willing to invest in its own labor force as well as its future growth. And of course, all these firm growth translates eventually into GDP growth. The last cross section that I'm going to discuss in this presentation is the firm's key employee risk. So far, what we have used as the broad brushed industry measure, but what we wanted to look at that what happens if despite that adoption of IDD, firms still mention or firms still feel the threat of losing its key employees. So based on one of the SEC regulatory requirement, the under MD&A section, firms are required to disclose any potential threat that they think that they feel that is the firm is experiencing or is about to experience. And one of these key threats also include that employee risk of losing key employees. So these key employees could be anybody, scientists, engineers, key executives, etc. So with the limited evidence that we have, is what we do is we text analyze the 10K filings of whatever firms we have from 1992 to 2016, because before 1992 we do not have any decent database for 10K filings. So we start our analysis, text analysis, and we pick up the phrase if the firm has mentioned key employees, key executives, and also mentioned loss of or firing of or departure of, not firing of, loss or departure of within the 20-word window around this key executive or key employees phrase. So if a firm mentions both the things, then we create an indicator variable called key emp risk. Here, that takes one. If a firm has, let's say, mentioned only key employees and does not mention departure or loss of within 20 words to the left or 20 words to the right window, then we do not allocate the firm's key employee risks to be 1. So it has to be combination of both. So when that happens, we assume that these firms are likely to feel threatened by the risk of losing their key skills set towards competitors. When that happens, these firms take the value of key employee risk. They interact that with IDD. And what we find is that the average patent value is there is no, although the firms that do not mention any effect of losing its key employee risk, they stand to benefit from IDD, just the usual case. However, there is a statistically not as significant, but there is statistically significant at 90% of confidence level that the incremental, or there is a decremental effect of IDD on these firms' real patent value. So basically, when we add these two, beta 1 plus beta 2, what this coefficient tells us that there is no effect of IDD on the real or nominal patent value of the firms, which still mention key employee risk, losing its key employee in its 10K, which goes on to indicate that if a firm does not stand to benefit from IDD to the extent that it still feels threatened of losing its own key skill workers, then the effect of IDD will not be significant for these firms. So the only set of firms which stand to benefit which do not experience the threat of losing key skill workers following the adoption of IDD. So having said that, so this is one of the robustness tests where we argue that if the adoption of IDD has resulted in higher innovation output, rejection of IDD, if you flip it on its head, it should result in reduced value of economic value of the innovation. And the good thing about this setting is, or a very interesting aspect of this setting is, so there is a recognition of IDD, and in the later stages, there is still some observation. We have some observation where these states have revoked that recognition of IDD, and where we construct indicative variable IDD rejection, which takes one if this state has rejected IDD after having adopted somewhere in the prior years. So when that happens, it should actually result in the reversal of the effect that we have observed because of the adoption of IDD. So what we observe in the first column is IDD rejection indeed results in the reduction of nominal patent value. It also results in significant reduction of real patent value, and the efficiency of R&D investment measured by research quotient also goes down. So the reversal of these three trend suggest that the recognition of IDD has been a good thing, or is a positive thing for firms, because they invest more in their firm in their future growth, and also that results in higher value oriented projects that they undertake. In addition to the test we have discussed, we also run following tests that cross-sectional heterogeneity based on industry's employee separation rate. Here, unfortunately, we do not have the data for how many employees actually left a firm out of their own volition, or how many employees were fired, because employees who were fired, IDD does not really apply on them. So in absence of this kind of segregation of the data set, what we do instead is we look at what is the change in the number of employees in a given industry. We take the average of all the firms in a given industry, and we construct an employee separation. What is happening? How many employees are separated from firms in a given year in a given industry? And what we find is that firms which are operating in industry with high separation rate tend to benefit more from the IDD. And also that, as we know, that not all the firms innovate, and not all the firms have a patent grant in all the years. And there's a large proportion of the firm in our sample where they do not innovate ever. The patent value always takes 0. In order to check the robustness of our estimate, we only keep those observations where a firm has at least one patent grant in a given year, and we find the results to be consistent with our mean results. And the last, what we do is so far what we have is a broad-based treatment group and control group. So in the last test, we first have the treatment firm, and our group of control firms is matched with these treatment firms. And when there is a match based on industry parameters, based on firm parameters for a given industry and a year, and when this match happens, that's when these two firms will be. So only matched pair of treatment and control group firms will go into our sample. We use propensity score matching, and we use nearest neighbor method with a caliper of 0.01. And when we run that matched sample test, the results are consistent to results for both the research R&D investment efficiency as well as the nominal and real value of innovation. They stand to be consistent with our main results. So in order to conclude, what we find is that following the recognition of inevitable disclosure doctrine, the economic value of firms' innovation increases. And this recognition also results in the improved efficiency of R&D investments. So these effects are more pronounced for firms operating in high technology firms, which we also call as new economy firms, new economy industries firms, as well as the industries that rely more on the firm's labor skills. So high is the dependence on the labor skills, hence the bigger is the threat. The adoption of IDD helps these firms to reduce that threat, which translates into better innovation by these firms. However, these effects are muted for firms that continue to experience risk of losing key employees. That's pretty much wraps the paper. Thank you so much for listening.
Thank you, Arkaja, for a very insightful and meticulously crafted paper. Can I invite participants to engage with the paper? If you have any questions or comments, please raise your hand and go ahead.
Hi, Amlan. Yes, please go ahead.
Hi, Arkaja. I hope you can hear me.
Yes, I can. Yes.
First of all, fantastic presentation. Thank you so much.
Thank you.
So I just wanted to understand what is the mechanism for the adoption and then rejection of these? What is the basis of this happening? So that's one question. And the other one is that do you also check for the trend between your treatment and control groups, whether so if you interact a dummy for the states that have adopted, with time does it show up as significant or not?
So first question, thanks for the questions, Amran. So first question, so we allocate the variable. We say that a state has recognized IDD when, for the first time, high court of that state gives a verdict in favor of the employer, citing in its verdict that there is a threat of inevitable disclosure doctrine. The first time it happens, we allocate variable the IDD to 1, and in the future cases, the first time a court mentions that we do not recognize, the same high court of a state says that we do not recognize the threat of inevitable disclosure doctrine, or even if we do that, we do not think we want to give a verdict in favor of the employer or the company, that's when we say it has rejected. So we are not I don't know, fortunately, incidentally, we are not the first one to construct this variable. We actually build on on the existing literature. We use 3 papers where they have, I think one is JFE, the other 2 are two are JFE, and the third one is SMJ paper, where they use data until 2016, and they have the sample of states where they have accepted and rejected IDD, but these data sets are not consistent. So whenever there was a conflict, I and my co-authors have actually gone through those legal cases and seen whether and judged for ourselves whether we say that these states have recognized IDD or not. So when these papers have a conflict, our judgment has come into the play. Otherwise, we solely rely on these papers. And to answer your second question, I completely agree that treatment and control variables should be interactive with time, and we have done that. So by the construction of it, the variable itself, if I could take you to that page, I think. Oh yeah, here it is. So for example, if you see that IDD, so basically this IDD variable is nothing but the treat variable multiplied by time. So it takes 1 only for the treatment in the post-adoption period. Like if you can see the pre-adoption period, even if it's a treatment state, it takes 0. So I completely agree with your point, and I think we have done it. If that's the question you had, please correct me if I'm wrong.
Yeah, that's all good. Thanks.
Thank you. Thanks, Amlan. So Monica, Dr. Monica has a question. Yes, or if we have time.
Yeah, please go ahead, Monica.
Hi, Arkaja. Thank you for presenting such a lovely and insightful paper. So basically, my question is what related to your methodology. Like you are talking about here, economic value of firms' innovation. So I would like to understand a little bit more as to how are you, measuring the economic value of firm innovation. So you talked about in your research question slide about, taking cumulative and normal returns. So that part I'm not too clear about. Is it like a window you are looking at, or is it like the announcement you are looking at, just like T minus and something like that?
So we do not construct the variable. We again take it from Noah Stoffman. So this is a JFQA paper where they look at a window of -1 to 1, where 0 is the time where the patent was granted. And they look at the cumulative abnormal return during that window, and then they also look at the change. I mean, and which basically encapsulates the change in the market capitalization of the company, which has happened because of the announcement of that patent grant. And let's say there are more than 1 patent grants in a particular day. Then what they assume is a clubbed or a combined effect. Then they are not able to distinguish the effect of which patent has led to what. So if let's say a company has received 3 patent grants in a certain day, they look at a -1 to 1 window, and then they measure the combined effect of those 3 patent grants using CAR methodology.
Okay, got it. Thank you, Arkaja.
No worries. Thank you. Thanks, Monica. So I guess, does anyone any question?
Okay. Are there any more questions or comments? Okay. Thank you. Thanks, Arkaja, again.
Thank you, Faisal.
Before we finish the session, I just wanted to introduce a few things about the Office of International Strategy and Mobility at Jsbf. The office is dedicated to providing opportunities for faculty and students of Jsbf in the international arena. We basically work for students. We basically work at 3 different levels. One is semester exchange or semester abroad for students who go to different universities internationally to spend their time. We also host students from other universities at Jindal as our semester exchange agreements. We conduct short-term programs for students, for our students, and also for students from around the world. These short-term programs are generally designed specifically on a topic which would help students gain some in-depth experience on a particular topic that they are interested in. We would be hopefully conducting, it's in the works now, a winter school in January 2022, which would be an intensive week-long winter school with a foreign university in collaboration with them. Apart from these two, we also have a few, and we are in the process of constructing more dual degree and master's progression agreements for our students who finish their BCom or are enrolled here can take the opportunity to enroll with other universities abroad. Currently, we have an agreement with University of New Brunswick, Nottingham Trent University. We are in the process of signing an agreement with Nottingham University. And there are other universities we are in the process of signing a few agreements. We also are in talks with Western Sydney University for a double master's progression for our students. So these are the opportunities that we provide for our students here. We also are at the nodal point at Jsbf for faculty members who want to collaborate with their peers in foreign universities abroad. We are currently in talks with Indiana University to host a virtual conference on disinformation and digital media. I would welcome our faculty members and other partners, international partners who are interested in collaborating with our faculty. It could be a conference, it could be a small workshop, or it could be other long-term projects, co-designed research projects that also would be very welcome. We are also in the process of conducting a few virtual co-teaching courses that could start probably next year with universities of Sydney and Macquarie University, where two faculty members could come together, one from our school and one from their school, and depending on their interests, design a course together and offer it to students of both the universities. This is specially designed for senior students. I would welcome our faculty members to think about topics or themes and potential partners with whom they can collaborate on these exciting opportunities. That is all about the Office of International Strategy and Mobility. I'm very thankful to Professor Nishika Bhatia and Ashavari for helping us organize the NIFTI lecture. And hopefully we will see you next month with another NIFTI lecture. Thanks a lot, Arkaja, for delivering the first NIFTI lecture this time. Thank you.